Hello, Djordje Romanic here. Welcome to Fundamentals of Weather and Climate. During a winter season, relative humidities outside and inside of a house can be profoundly different. In other words, air inside of a house can be substantially more dry than the air outside. And that's what we will demonstrate in today's video. And this is a very important concept for the human health as well as the plants that you have perhaps in your apartment. So consider this to be a surface of the earth, and over here we have a nice house, but I will just make it like square without roof, so I have more space for plotting. And we are assuming it's a winter season. So in a winter season, let's say temperature outside is negative 10 degrees Celsius. This is not crazy value. This morning in Montreal was minus 16, so probably now is about negative 10 outside. So this is completely normal in mid-latitudes. Now let us assume that relative humidity outside is 100%. And it's snowing outside, so this is also not very crazy assumption. Now at negative 10 degrees Celsius, and in this relative humidity, we know that the actual water vapor pressure equals saturation water vapor pressure, hence relative humidity 100%. And over here, these values are, for this temperature, this value is 2.87 hectopascals. It happens that I know it. Because relative humidity is 100%, then you also know from my video on dew point, as well as on my video on wet bulb temperature, that these two are equal, and in turn they are equal to the actual air temperature. All these are explained in my previous videos. So you see how atmospheric sciences connect. That's typical of any natural science. You cannot now decide to study wet bulb temperature and know nothing about dew point or actual temperature. It doesn't work like it. You have to know everything. You can have this approach in literature. You can just read Shakespeare and you don't care anything about writers from the rest of the Europe or the rest of the world. But in the case of atmospheric sciences, you have to know everything because everything is connected. And that's why I have this detailed playlist, so you can follow video by video and understand all of these before you watch this video if you do not understand some of this. Okay, so now let's go indoors. Here is a house, and of course air from outside comes in through windows, doors, maybe you have air conditioning that is warming the air that comes from outside. And we assume now, very important, when this air from outside comes in, no water vapor is added or removed. Now, that means no water vapor is added or removed. Well, it means that the partial pressure of water vapor inside of this house will be 2.87 hectopascals. Because, I just told you, this amount of water vapor entered together with this air inside. But inside, hopefully in your house, temperature is not minus 10. For example, in my room, temperature is 23 degrees Celsius. So that's comfortable temperature. So the question we now want to ask ourselves, what is relative humidity inside? We saw that relative humidity was 100% outside, but what is it going to be inside? Well, we know that relative humidity is equal ratio of the partial pressure of water vapor divided by saturation vapor pressure of water vapor times 100 to give results in percentages. And this ES depends on temperature. Depends on temperature following our famous Clausius-Clapeyron equation. If here is temperature, here is saturation water vapor pressure, and it's an exponential function that looks like this. Again, I have entire video on that. Now, it happens, again, that I know that the saturation vapor pressure at this temperature, 23 degrees, is 28.1 hectopascals. And the actual water vapor pressure inside is the same as outside, 2.87 times 100. And when you do this calculation, you will get that the result is around 10%. Isn't this absolutely amazing? Relative humidity outside is 100%. If you bring that air inside, relative humidity of that air is about 10%. That is extremely low value of relative humidity. And in fact, not very healthy for long exposures. Because you can get sore throat, your skin will get very dry, you might get rashes, the plants don't like it, animals don't like it, and so on. So what's the difference? What gives? Why is this happening? Well, it's happening because at such a low temperature, air gets saturated very easily. 2.87 hectopascals of water vapor pressure saturates the air. But when you bring this amount of water vapor into the indoor environment that is characterized by much higher temperature, then this amount of water vapor is not even close to saturation. Saturation is about 10 times above this value. As you can see, 2.87, 28.1 is about 10 times difference, hence 10% relative humidity inside. You can also calculate that wet bulb temperature inside is about 16 degrees Celsius. Again, you can see equation for wet bulb temperature in my video on wet bulb temperature. And you know from that video, the larger the difference, T minus TW, the higher potential for evaporation. Well, this difference inside is huge. Difference outside is 0. T is minus 10, TW is T. So difference is 0. So outside there is no evaporation. Well, that's why relative humidity is 100%. But inside, actual temperature is 23 degrees Celsius. Wet bulb temperature is 16. What is this? This is 4 and 3, 7 degrees Celsius difference. And that means that potential for evaporation is huge. And that means that water from your skin will evaporate very easily, making your skin dry. Plants will evapotranspirate and start decaying. So that also means, listen to this, which is maybe counterintuitive. You have to water your plants more often in winter than in summer, which many people don't know. But they think, oh, in summer it's high temperature, everything is warm, you have to water plants. Yes, of course, you have to water plants in summer. But in winter, air inside can be profoundly dry under the assumption you don't add water vapor to that air that comes from outside. And because that air is so dry, the potential for evaporation is huge, and water from plants evaporates readily, so you have to water plants more often. This is why it is very beneficial to have moisturizers in house in winter season to make air more wet, more moist. It is if one doesn't have these machines, then it is beneficial to have a big bucket, big container of water close to radiator, so that water can evaporate, and then when this air comes in, you add moisture to that air. And in that case, you increase relative humidity because you don't come in with 287 hectopascals. In other words, you come in with 287 hectopascals, but you artificially, through moisturizer or some bucket of water that is evaporating, add more water vapor to the air, increasing relative humidity, and you will feel more comfortable in such an environment. Please make sure to like and subscribe, share this video, implement these practical suggestions in your household. And until next video, goodbye.